Shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. See ya.
Let's learn the new way. Welcome to the Daily Dose of Mathematics, guys. Today we're doing financial mathematics. We started with one of the most challenging questions that we got. It's similar to what they got in November 2024. So we felt that we should start here. Itu, what is our question for today?
So that since we're dealing with example one of the difficult questions, I remember this one was ours. It says number one, a couple takes out a loan of 1.5 million over 25 years at the interest rate of 13% per annum compounded month.
It's compounded monthly. Okay, now guys, here's what we're going to be doing. We're going to be taking the solution, put it on the senior marker. We have a song that we call the present value song, and then we also have what we call the financial maths keyword decoder. This financial maths decoder, you should have it, guys, every time when you're working with financial mathematics. It tells you some of the keywords that they are using. We took some previous examinations and check some of the keywords that are associated with a certain formula. So this formula, this page that it is showing now, you should just request it. You can get it on the comments. Okay, let's check based on what you saw them. Which one should we use here? Based on the financial mathematics keyword decoder.
Okay,
they say a couple takes out a loan.
Yeah, a couple takes out a loan.
A loan of how much?
Highlight the keywords.
Yeah.
It takes out a loan of 1.5 million.
So we're taking a loan of 1.5 million.
Yep.
Okay, so it's a loan.
Yep.
Now let's go and check in our keyword decoder. What is associated with the loan? Which formula should we use? Especially if it's going to be repaid in regular monthly installment.
Yeah.
Yeah. Remember, 1.5 million you can't pay it like once.
Okay, so then on our exam question phrase, we have the one that says take out a loan.
Yeah, take out a loan.
Yeah.
Okay, which formula is associated with that?
It's the present value formula.
Yeah, guys, if you see someone saying taking out a loan, we're going to be using the present value formula. And then what does the present value formula say it do?
Present value formula is X.
It's X.
Oh, it's P is equaling to X.
It's PV is equaling to, yeah.
X, open a bigger bracket.
We are going to open a bigger bracket.
And then open a small bracket.
Open a small bracket.
1 minus.
1 minus.
Open another bracket.
Open another bracket.
1 plus.
1 plus.
I. Close the bracket.
Close the bracket.
To the power of minus n.
Power of minus n.
Close the bracket.
Close the bracket.
Close the bigger bracket.
Close the bigger bracket.
All over I.
All over I. Okay, sure. So this is the formula that we're going to be using, guys. Now we're going to be reading the statement. While we're reading the statement, we're going to be collecting the data to check what is it that we have, what is it that we're looking for.
Yeah.
Okay. Now let's go to the statement again. They say we're going to take out a loan for 1.5 million.
Yeah.
Now we're taking the loan when? Is it in the future or is it today?
We're taking the loan. They took the loan today.
Today. So it's going to be the present value.
Yeah.
It's the money that we're taking today. So we're going to tell them present value. Write the formula first. Don't forget to start by writing the formula.
Yeah, we have the formula. Is the formula.
Okay. So we're going to say present value is equaling to,
which PV is equaling to 1.5 million.
So it's R1 and then it's 500.
Yeah.
So it's 500 and then it's going to be 3 zeros after it.
Yeah.
1.5 million. Now we should be careful with such questions whereby they ask you to write the 1.5 million in numbers. I think they said 1.5 million one. So now we should be able to say how to write 1.5 million. 1.5 million case, it says after the one you should have 6 numbers.
Yeah.
So it's going to be 1 and then it's 500 and then it's triple zeros.
Yeah.
Okay, sharp. And then what did they say after that, Itu?
They say they are paying it over 25 years.
So they're paying it over 25 years. It's N, this one again.
Yes.
So N is going to be equal to 25. For now, we just say 25 again. Yeah. We don't know how is it compounded. Okay, N is 25, yeah?
Okay, 25 at an interest rate of 13%.
So interest, we're going to say interest rate is going to be, I is going to be equaling to 0.13 again.
Yeah.
Sure. So we're not done again. We still have to get the compounding.
Yeah.
Yeah.
Compounded monthly.
Compounded monthly, we divide by 12 on the 13 again.
Yeah.
And then we go to our 25 and then we multiply by 12 because of this compounded month.
Yes.
And then if we say that, we get something like 300 again.
Yeah.
So if you type that in your calculator, guys, if you say 25 multiplied by 12, it gives us 300, yes.
Okay, so then our PV is equivalent to 1.5 million.
Yeah. Okay, what are we looking for? We haven't checked. I done reading the statement.
Okay, let's read this. Let's continue with the statement.
Yeah.
And then so then it says the repayment starts 1 month after the loan is granted.
Okay. Now let's do the timeline here. Let's show them which on the timeline this is normal. You take out the loan on T0. you don't have to pay anything, ne?
Loan.
Unless you are paying a deposit, and then you start to pay after T1, okay?
Yeah.
Which is going to be normal, something which is normal, which is something that you shouldn't worry about, okay? Sharp, and then what do they say?
Okay, they say we should calculate their monthly payments.
So we are going to say X. It's something that we don't know. Again, X represents the monthly installment.
Okay, our X is unknown.
Yeah, so we're going to be looking for X.
Okay,
so for us to collect the maximum max, first we write the formula. The next thing that we do, we collect the data. Ne? After collecting the data, then that's when we're going to substitute. Ne?
Okay.
Let's go and sub. We're going to sub on PV.
Okay, we have, let me start by writing the formula on our smart notebook.
Okay.
PV is equal to X,
Yeah.
open our bigger bracket,
Yeah.
open a small bracket,
Yeah.
1 minus, open another bracket, 1 plus I, close the bracket to the power minus N, close the small bracket, close the bigger bracket, all over I.
Okay. And then the data is already collected, is fine.
Yeah.
Okay. So we have, instead of PV, okay?
Yeah, instead of PV, we're going to say we have 1.5 million.
500.000.
Yeah.
Okay. Is equaling to?
Is equaling to. Now,
X.
you know, we do know what X is unknown. So then we're going to just say X.
Okay. Open bigger bracket.
X, open the bigger bracket.
Open a smaller bracket.
Open a small bracket.
1.
Minus.
Open bracket.
Open the bracket.
It's 1 plus.
1 plus 0, 1, 3, all over 12.
12, okay, close bracket.
Close the bracket to the power minus 300.
To the power minus 300.
Close the bracket.
Close bracket, close the bigger bracket.
Close the bigger bracket.
All over. 0.13.
0.13.
All over 12.
All over 12.
Okay, sure.
So
now that we have this, we are going to try to get X.
Yeah.
Now, the best thing that we can do here is to try to cross multiply with the denominator.
Okay.
So if you cross multiply both sides, and then we say we have, basically we're going to tell them which we have 0.13. 0.13 all over 12.
Yeah.
Multiplied by
1.5 million. Yeah.
Yeah. And then to avoid making many steps, we're also going to divide by the bigger bracket here, also here.
Yeah.
And then we say, what is the bigger bracket? It says bigger bracket again.
Yeah.
And then we have open smaller bracket 1 minus again.
Yeah.
We have an open bracket again.
Yeah.
1 plus 0.13 all over 12.
Okay.
Close the smaller bracket, and then we say to the power minus 300.
Okay.
Close bracket.
Yeah, let's close the bracket.
And then we close the bigger bracket again.
Yeah.
And then we say all this is equal to X. Yeah, but how did we do this? Basically, we started by multiplying again. It is not as if we're going to get max if you show them, which, okay, I multiply first. What is important is that we need to show them this is what we're going to be having, basically. The other thing that Elena could have done, they could have just taken the whole bracket, this whole thing here, and then divided by it. They have the present value on top, and then they have a fraction, and then they are going to, but instead of that, on their calculator is going to have a fraction. Which is going to be untied. Okay, let's move on now. We're going to put this in our calculator.
Okay.
Exactly the way it is.
So then our calculator, we're going to have, firstly, a fraction of 1.5, 1, 2, 3.
Yeah.
And then we open a bracket.
Yeah.
Oh, let's just multiply. Multiply by a fraction.
Yeah. 0.13.
Fraction of 0.
0.13.
0.13.
Yeah.
All over 12.
All over 12, sure.
Then all over again.
Then all over, yeah.
Open a bracket. Guys, this is a case calculator. It doesn't matter which one is a bigger.
Yeah, it doesn't show bigger
so
brackets.
Don't hand bigger brackets here. You're
it's
gonna
the
be
same
haunted.
bracket,
So then you're gonna have 1 minus.
Yeah.
Open the bracket.
Open bracket, yeah.
1
plus
fraction of 0.13.
Yeah.
All over
12.
Close the bracket to the power minus 300.
To the power minus 300. Okay, yeah. Close bracket.
And then we're gonna close our first bracket.
Close the
other bracket. So then the last one is the bigger bracket.
Sure.
Then our X is gonna be 16,917.
R 16,000.
R 16,000.
Yeah.
917.
917.
53. 6.53.
Okay, sure. Now, if you don't know how to round off, guys, you can make your calculator to round off. You can fix it. If
Yeah.
you feel which you are going to make mistake, there's no need for us to make a mistake on rounding off. It's money. That's why we round off two decimal places. We're going to play a song and put this in the senior marker. No?
Okay.
Okay, you started by copying the solution first, okay? Copy the solution.
Yeah, the solution is done, copy it.
Okay, play the song before you go to the senior marker. This is a present value song, guys. Let's just a little bit.
Lalela, we talking about the money today. Money today. The present value. The big lump sum. Big lump sum. Don't mistake it for the future. The money is here. Money is here. Listen to the story. Read what it says. Read what it says. Takes out a loan to cover the days. Cover the days. Repays a bond for the house or the car. House or the car. Wins the lotto, now you're a star. You're a star. Retires and gets a pension each month. Pension each month. Receives an inheritance. Withdraws the funds.
Marking breakdown. Here is the official caps-aligned evaluation of your working in the provided image. Image_BBFC68 link to .png. Step. Examiner's evaluation. Mark allocation. Formula. Correct present value annuity formula selected. 1 mark, M. Substitution 1. Correct substitution of I equals, frac. 0, 13, 12, and N equals 300. 1 mark, A. Substitution 2. Correct substitution of P_V equals 150000. 1 mark, A. Algebraic isolation. Flawless algebraic manipulation to isolate X. Not awarded a separate mark, but excellent practice. Final answer. Calculation is slightly inaccurate. 0 marks, CA. Total. 3/4 marks. Corrective feedback. Line of error. The final answer line, therefore X equals, text, R16 917, 53. Logical flaw. You adhered perfectly to the principle of not rounding off prematurely, and your algebraic manipulation to isolate X before calculating is structurally flawless. However, the final sense value, 53C, is slightly off from the true calculator output. This usually happens due to a simple keystroke error or not using the fraction template correctly when punching the final block into the calculator. Socratic question. Using your scientific calculator's fraction button, try inputting the exact expression, frac. 1500 times, frac. 0, 13, 12, 1, 1 plus, frac. 0, 13, 12, caret, minus 300, in one single go. What exact value do you see on your screen to 3 decimal places before applying your final rounding? Caps and formal notation compliance. Variables declared. Listing your given variables at the top, P, X, N, I, is excellent practice. Formula. You accurately stated the correct standard formula P_V equals, frac. X, 1, 1 plus I, caret, N, I, before substituting, which is a strict requirement for full method marks. Units. You correctly remembered to include the rand symbol, R, in your final statement. Coach's summary. What you did well. Your structural layout is top tier. By listing the given data, substituting it directly into the standard formula, and then cleanly isolating X algebraically before ever touching the calculator, you completely eliminated the risk of premature rounding errors in your written working. Showcasing this exact step-by-step layout on the presentations and worksheets for your upcoming free online financial mathematics lesson this July will give your invited learners a perfect blueprint to follow. Area for improvement. Calculator execution. When you reach that beautifully isolated expression for X, take a deep breath and double-check your keystrokes on the calculator. Ensure the brackets and fraction templates on your screen perfectly match the algebra on your page before hitting equals. Take a stab at recalculating that final expression and let me know what you get.
Siyabonga for pulling through the lesson. Hope you caught that daily dose of magic, like the video.